All right, so this is chapter 19, this section, like you can see, air pressure and wind. I think this is probably the most important section as far as understanding why we have the weather that we have, and also being able to predict the weather and what type of weather that we'll have. I know it's easy now to, to get the weather report to predict the weather, because you can just kind of look, at a website or an app or whatever, and a highly trained professional will tell you what's going to happen. But in the instance of just having a map with some information, this gives you, or this section kind of, in my mind, kind of gives you the best information as far as being able to use the information to predict what type of weather we'll have and all that. All right, so this first slide, oops, that. First slide, just definition, air pressure. We've seen this before, seen this a few times before actually. The pressure exerted by the weight of air, and it's exerted in all directions. Our bodies respond by pushing outwards against that. That's what happened, or that's the reason why, if you go, either up a big hill or down a big hill, or you're in an airplane during takeoff or landing, and your ears pop, that's because there are external changes in pressure. So your internal pressure needs to change and needs to equalize. So that's why your ears pop, or you have to kind of hold your nose and then kind of, with your mouth closed, try to kind of blow outwards, whether your nose plugged up, or you can open your mouth really wide. Another one is to kind of keep your mouth closed, plug your nose, and then try to swallow. Chewing gum, all those things kind of equalize the pressure in your ears with the outside world. But all right, so if you were curious about what the air pressure was as far as measuring it, you would use an instrument called a barometer. This is, very basic and traditional style of barometer that uses a reservoir of mercury, which is an element that's a metal, but it's a liquid at room temperature. So you have the mercury in here. Air pressure pushes down on that. The more air pressure there is, the further it pushes the mercury up the tube. If there's less pressure, it doesn't push up as much, so it's at a lower value. And actually, air pressure is measured in millimeters of mercury, so mmHg. Even still. So if you're trying to measure air pressure, use a barometer. Okay. Another vocab word is wind. Something we've all experienced, something that's very easy to experience if you just go outside. Some days, obviously, windier than others, but anytime there's air moving in a specific direction, that's wind. Something that is pretty important is that air moves from high pressure to low pressure. Just pretty much with everything, in the world is like that. In the natural world, things move from areas of a high concentration to low concentration. Because there's an area of high pressure and an area of low pressure, it wants to equalize, it wants to reach an equilibrium. So one way to kind of visualize this that I think works fairly well is you can visualize high pressure and low pressure as hills and valleys. So if high pressure would be a hill and low pressure would be a valley, high pressure systems, things are moving away from that. If you have a ball on a hill and it's just, set the ball down, it can roll down that hill. Low pressure being the valley, things are moving into that high pressure, things are moving away from it because it's a hill. Low pressure, things are moving in because it's a valley. Like I said, I think it's a pretty decent way to kind of visualize this and think about high pressure and low pressure. That should kind of serve you pretty well for this little section. Unequal heating of the Earth's surface that leads to pressure differences. I think I talked about this, or at least touched on it last week. We talked about how land both heats up and cools down more quickly than water. So that leads to uneven heating. The land is going to get warmer faster. So that's going to cause heat to rise because of convection. Areas where there's water, there's not going to be as much heat rising off of that. So it's going to lead to pressure differences, which is going to lead to wind, and that stuff is going to affect weather systems and weather patterns. So as far as these things that control wind or affect wind that we're going to touch on, pressure differences is going to be the main one that we'll cover. The Coriolis effect, it's just going to be basically a mention of it. It's an involved and complicated topic. There have been countless scientists that have made careers studying the Coriolis effect. And then friction, kind of touch on there as the last little piece. Okay, so some pressure differences. Pressure gradient is a change over a distance, a change in pressure over a distance. So this map shows several pressure gradients. Your gradient can be used to describe anytime there's a change of something over a distance. Even like in the background of the slide, there's a color gradient. So down here at the bottom, it's basically maybe not white, but pretty close to white. Whereas up here, it's pretty much yellow. So that distance, that would be a color gradient, going from white to yellow or whatever. And on the map, like I said, several pressure gradients. These values, these numbers, those are air pressures. So, moving all around the map, you can see where there are pressure gradients. Here it's going from a lower pressure to a higher pressure. Here's, a higher pressure to a lower pressure. So those are all pressure gradients. And that'll come into play momentarily. All right. Okay, so the lines on the map, just like I think it was last week, one of the vocab words was isotherm. So on a map, there were lines on a map, and everywhere along that line, it was the same temperature. So therm, meaning heat, isotherm. So these are isobars, and the same concept. Everywhere along, this line, it's the same air pressure. So bar is kind of the root that means pressure, or sometimes it can be used as a prefix. With these isobars and using the isobars to look at pressure gradients, it can tell you about wind speed. So anytime the isobars are close together, so like here would be a good example, like where they're close together. Here's another little, an area where they're fairly close together. Anytime they're really close together, that means that you have a big change over a short distance. So it's going to be a steep pressure gradient. So you can think of it as a fairly steep pressure gradient. So if that's a hill, if we go back to the hill and valley kind of thing, put a ball on that. By the time it gets down to the bottom, it's moving pretty fast. It's steep. So anytime you have that steep pressure gradient, those close isobars, that's telling you that you're going to have high winds, because air from the high pressure area is moving into that low pressure area at a very steep, steep angle. So it's moving fast. Where they're wide and spread out, kind of like this whole area over here, it's much weaker. So, things are still moving. If you have that ball and it's moving down that kind of incline, it's still moving, but not nearly as fast. So you're going to have slower winds. The winds aren't going to be as strong. Usually end up with a kind of a light wind. So the fact that the isobars will tell you about the pressure gradient, and then that pressure gradient indicates how fast the wind is going to be in that area. And again, because this is low, because that's a valley, this stuff is moving, that wind is moving into that area. And then high pressure, that's moving out in all directions away from that area. Okay. Moving right along. Okay, Coriolis effect. Like I said, it's pretty complicated. The main thing is the Coriolis effect has to do with how the rotation of the Earth affects things in the atmosphere. Be that air pressure that's in the atmosphere, clouds, projectiles that are moving in the air. But for most of us, we don't really do anything or deal with things that are suspended in the air long enough to be affected by the Coriolis effect. But just briefly, like with this diagram, if you have, let's say you have a huge cannon at the North Pole and your target's down here on the equator. If you fire that cannon aiming, at your target, by the time that cannonball reaches that point, the Earth has actually rotated underneath the projectile as it's flying through the air, and you would miss the target. So, if this was your target and you wanted to hit that, being in the northern hemisphere, you would need to aim it over here or somewhere over there. So again, it would be deflected and actually hit what you were looking to hit. Like I said, most people don't deal with things that are in the atmosphere and in the air long enough for this to make an effect. It's just not real common that people need to do that. It's not as big a deal if you're going east to west, because the Earth is just rotating, so it's not like things are being deflected one way or the other. It could affect things, whether things were moving towards towards the aiming point. But like I said, it can get as complicated as you want it to get. But for us, anything with Coriolis effects, just remember that it just has to do with how the rotation of the Earth affects things in the atmosphere. That'll work for what we need. Friction. So friction slows air movement. It can change wind direction. Friction, as far as air movement, things like that, that would include things like large land masses, oceans, mountains. These are big things. It's not, just like something, being rough to the touch, like sandpaper or something. Big things that get in the way, can affect wind. And then also jet streams. So it says rivers of air. It's a descriptor. It is kind of a band of air that moves, and it does change its course. High altitude, very high speed. Typically in North America, it kind of hangs out uh, right around the border between the U.S. and Canada. Like, but it fluctuates. It moves, a little further north. It moves a little further south. Uh, but it does affect our weather quite a bit. If the jet stream kind of dips down, that'll bring colder air from Canada, and sometimes all the way from the Arctic down. So we get, some kind of random cold spell like, we had over the past couple of days. But yeah, just, high altitude, high speed winds that do affect our weather patterns. All right, so that's it for that section. We'll do this last little section and then we'll call it good for the day. All right, so here are a couple of important ones. Cyclones and anticyclones. So cyclones are low pressure systems. And this CCW, that just means counterclockwise. So these are winds that are moving in a counterclockwise direction. Anticyclones, high pressure, and it's moving, those winds are moving in a clockwise direction. So for those of you that don't know what direction the hands on a clock move, this is the direction they move. They move clockwise, counterclockwise. So with a cyclone, again, if you think about the hills and valleys being low pressure, the lowest pressure is at the center of it. Also with cyclones, things like tornadoes, hurricanes. I'm not gonna write it all out because it's difficult with the mouse. Tornadoes and hurricanes, those are both cyclones. So those are big storms. Any large storm is going to be low pressure, so it's going to be a cyclone. And sometimes tornadoes are even described as cyclones. But like I said, these are important things. So I would remember that cyclones are low pressure, anticyclones are high pressure. And this is basically just the same information, but with kind of that hill and valley diagram with the terms kind of thrown in there. So anticyclones, high pressure, cyclones, low pressure. And again, low pressure cyclone, things are moving in. High pressure anticyclone, things are moving out from that point. Which you can kind of see with this map. You can see it actually. So here we have this high pressure system. These arrows show the wind direction. So they're kind of, I guess we've got one there. There. So if you see that, notice that this is moving in a clockwise direction. And it's moving away from that center point. Those winds are moving out from that central point. With low pressure, things are moving basically in a counterclockwise direction, and those are moving towards that center point of that low pressure. This one's kind of like a toilet flushing or something. But again, I would remember those. Could be good to know. Something else that's important, especially when you're talking about how to predict weather. And again, it's super easy to get weather, forecasts. You just, pull up an app or a website, whatever. But if you know that there's either a high pressure system approaching or a low pressure system, Uh, with low pressure systems, that leads to cloud formation and precipitation. The reason that happens is when you have low pressure and things are moving into that low pressure area. So you have, wind that's moving into that area. When it kind of collides with the other wind at the bottom of that, it forces everything up. And when it does that, that air has moisture in it. And when you force that higher up into the altitude or higher up in the atmosphere, then that forms clouds. And then you get precipitation from those clouds. And when you have a high pressure system, that gives you clear skies because the air that's coming from that high pressure area, it's already dried out. It's, the moisture that would form precipitation or form clouds and form precipitation, it's already been removed. It's already gone. So it doesn't have the moisture in it to form form the clouds and form precipitation. So you get clear skies. So low pressure, you get cloud formation and precipitation. I would star and remember these. And then high pressure, you get clear skies. So if you know that if you want to have a picnic, a couple of days from now, and you know that there's a high pressure system moving in, that's going to be, a good thing. That's going to probably be clear and dry. All right, so a couple of kind of major, like global wind patterns. The first one is the trade winds. So trade winds are easterly winds. Anytime you're talking about winds, you talk about the direction that they're blowing from. So when easterly wind blows from the east to the west, and also on both sides of the equator. So those would both be considered the trade winds. So named from, back when they're sailing ships and trading, it would go from, Europe, out in Europe to the kind of the New World. And again, notice that they're on both sides of the equator. The winds on both sides of the equator basically like mirror images of one another. Okay, next one, the westerlies. So these are the winds that affect North America and the US the most. So they are from the west, both in the southern hemisphere and the northern hemisphere. And again, this is what drives the vast majority of our weather patterns and our weather systems is west to east, and more specifically, kind of a southwest to northeast path. It's, more often than not, weather systems follow this this path. Not always, but most of the time. So those are the westerlies, and again, it's the same on the northern hemisphere as the southern hemisphere. And this just shows all of them. So notice the trade winds on either side of the equator from the east, and then you have the westerlies from the west, and then the polar easterlies from the east. So they alternate, east-west, east-west. But the westerlies are the ones that affect us the most. And then as far as like pressure systems and how the continents and land influence things, southern hemisphere is the only place on Earth where there's a continuous pressure belt. So if you look at a map in the northern hemisphere, because here's the so that's the equator. In the northern hemisphere, you have all this land, so you have all these different, all these different pressure systems That's kind of continued from that one because the land breaks it up. You have mountains and uneven heating and all that stuff. You get in the southern hemisphere, especially the southern part of the southern hemisphere, there's nothing there. I mean, there's a little bit of land, and there's the Andes, and that kind of starts to break things up some on the southern tip of Africa, Australia. But below that, I mean, it's pretty much just a straight shot all the way around. So the oceans and the areas around Antarctica have high winds, very rough seas, very powerful storms, because that pressure and that wind just goes. There's nothing to really get in its way like there is in the northern hemisphere. There isn't a huge body of land. There isn't a mountain range to slow that down. So it just keeps going and builds and builds and gets stronger. So that's why there's such extreme weather in Antarctica and down around Antarctica. It doesn't really affect us a ton because we're up here, but it does affect that area down there. All right.